All right, so if you're looking at cross-sectional volume, let me show you what this is all about. So find the volume. This is just an example to give you a visual idea of what's going on with this. Okay, so basically, we're going to use this shape as our base and build a shape from it. Okay, so find the volume. If the cross section's perpendicular to a fixed diameter of circular base are squares. So basically what that says, okay, you have some chords that are perpendicular to the x-axis, and we are finding the volume of a shape formed by squares. As you move across the circle, the square obviously has to get bigger because the base times the height have to be the same, right? So the squares actually have to grow bigger from 0 to however big that one is, and then back down to 0. Okay. This is what you're doing. You're integrating the shape formed by that square sweeping across the x-axis. Okay. Here's the shape. This is the shape. Visually, they are kind of difficult to see sometimes, but the math is really not that difficult. Okay. That's what I was trying to do. So there's your solid. What is the volume of that solid is the question.
42.67.
Right, got it. Okay. You can use integrals to calculate that.
What's the equation at the top?
Okay. This equation is the equation of that circle. It's radius r. So normally it would be x squared plus y squared equals r squared, right? For the circle equation. We've just solved for y, so we can plot it on the xy axis. Okay. So that's an example of a shape that you're going to be finding the volume of. What is the length of the base of each square? So you have to find square volume, or square area, sorry. Can anybody tell me the size of that, any one of those squares?
You can say one of those 4.
How would you know that? You don't even...
The radius is 2, so the diameter would be 4.
Right. So one square would be 4 by 4. But you have an infinite amount of squares in there. Can you do that for that many? Okay, so you have to use that formula. Okay. And I'll show you a couple examples, but this gives you a visual idea of what's going on, right? It's very whack. Thank you for that. Okay. So okay, longest theorem title or definition that you've had all year. A of y is a function. It is the area of the horizontal cross-section at height y of a solid extending from A to B. Can you write that as an integral? Think about how you might write that as an integral. Anybody? Integral from A to B. Did you read it out of the book? Punk.
See, I had the book open and wasn't going to say anything.
Okay, what does that tell us? That could be one interpretation. All right. The first challenge of these is interpreting what the problem says. Okay, so let me show you an example. Compute the volume V of a solid. Here's what it looks like. Example, compute volume V of a solid. So here's a solid. Whose base, pay attention, is the region between 4 minus x squared and the x-axis, and whose vertical cross sections are semicircles perpendicular to the y-axis. Ta-da! It's magic. Okay, so again, interpreting is half the battle. So here's the parabola. And we're gonna,
perpendicular to the y-axis are semicircles. So they actually have to come up like this. They're perpendicular to the y-axis. So here's the y-axis. They have to be perpendicular to it. And if you can draw three-dimensionally, the question is, how do we calculate the volume of that shape? Okay. We need, okay, first thing you need, it's got to be in terms of y.
That be zero. That be zero.
A. This is the formula. Remember, every time you have a formula you're going to use, write it down so you remember it, memorize it. You need to. Yeah. Okay. This integral is in terms of y. So we need to rewrite this to be x equals.
1 4. Or excuse me, negative y plus 4. How about 4 minus 5? Yeah, but this is work of white less. See, Mr. Darcy knows what he's doing.
Subtract the 4, multiply by -1, square root it. Okay. So we rewrite in terms of y. Okay, what's the area of a half circle? What's the area of a semicircle? Okay.
2 pi squared over, oh yeah.
This R needs to be in terms of y. Okay, so basically, what is that value? What is R? So you have pi r squared. We need this in terms of y. That's our base. This is our base. So it basically is that right there. Okay. This is our radius because it's that value right there. The radius of that semicircle. It's the base. The base always gets plugged in. Okay, now we can write our integral. What y values does this go from? Ah, y value 0 to 4. And then the function, okay, 1/2 pi can hang out here. What does this become? Right there. The most difficult problem of the year just became the easiest integral you've done in a while. Yeah, you can write pi over 2. That doesn't matter to me. You've just found the volume of that shape if you complete it. Thanks for that. Is the units cubed. That's the volume. Yep. If you do the integral. All right. Where are we at? Okay. These problems explain to you basically what you need to do. Okay. The vertical cross sections are perpendicular to the y-axis. Okay. We need to have this in terms of y. And it's a semicircle, so we need to have the area of a semicircle. Right, so semicircles, that's our area formula. And then perpendicular to the y-axis tells us to rewrite it in terms of y. Because it's a constant, it doesn't affect the integral at all. So on these problems, Leon, Corey, the base, this function is always what you're going to use for r, or if it's a square, that's the base. Okay, that function is, whatever that function is always your base. It's your radius or your square base. Okay, it's always, always, always. Keep that in mind. Okay. And then you combine these two to create your function in terms of y. So you're integrating an area to get volume. I think that's enough. Throwing enough at you for one day. Yeah, we don't mess with that. We leave that to Stephen Hawking. Six. Okay, give those a shot. 4 problems.
It's gonna be a C. A D? What do you see? Well, since it's going to be, it's decided.
This is all I want. Tomorrow we are going to score this. We're going to talk about it. But I want you to try these before I give you anything else. Okay?